So let's take a look at some things that we know from one of our previous lessons. So we call the exponential versus the logarithmic function. So the inverse of an exponential function is a logarithmic function. This graph should look familiar to you. Actually, both these graphs should look familiar to you. And so the blue graphs that you have here are exponential functions. The first one is an exponential function where the base is greater than 1. So something like y equals 4 to the exponent x, for example. And the second one is a logarithmic function with a base of b and an answer x, and y represents the answer. So here's how you would write a logarithmic function. We talked about that in lesson 2 as well. Okay? This one here is a exponential function where the base is between 0 and 1. So something like y equals 1/2 to the exponent x. And so here's a corresponding logarithmic function with the base that's between 0 and 1. So as a logarithmic function, this can look something like y equals log of a base of 1/2 of x. Or y equals log base 4 of x. Okay, so that's what they would look like in logarithmic form. Okay, some properties of exponential and logarithmic functions. Remember that they are inverses of each other, so you'll notice that a lot of their properties are opposite. So for example, for an exponential function, the domain is all real numbers since it continues infinitely to the left and to the right. The range is only positive values of y since the graph is above the x-axis. So because the graph is above the x-axis since there is a horizontal asymptote at y equals 0. There's no vertical asymptote, no restrictions there. There's no x-intercept since there is a horizontal asymptote at y equals 0. And the y-intercept is at 0 and 1. For the logarithmic function, you'll notice that the domain of the original function is the same as the range of the inverse. And the range of the original function is the domain of the inverse. Okay? So notice that the logarithmic function exists only for positive values of x. Now if you think back to the warm-up, that's why we couldn't find the log of 0, or the log of -3, or the log of -10. That's why these values never existed, because they only exist for positive values of x. The range is all real numbers. The graph continues infinitely up and down. There's no horizontal asymptote in this case, since the graph continues towards positive and negative infinity for the y. There is a vertical asymptote in this case. Notice that the horizontal asymptote has become a vertical asymptote, and there was no vertical asymptote in the exponential, and now there's no horizontal asymptote in the logarithmic. In terms of the intercepts, the exponential function had no x-intercepts, but the logarithmic function does. If we look back at the graphs, you'll notice that both of the red graphs cross through the x-axis, but they do not cross through the y-axis. Okay? And so you'll notice that these properties have also interchanged between the exponential and logarithmic function.